A very good morning to all of you. My name is Dr. Vishalli, and I'm working as an assistant professor in the Department of BSc Computer Science at IIMT College of Science and Technology, Greater Noida. Today's topic of this presentation is cathode ray oscilloscope. So let's begin with this. So first of all, a brief introduction about the cathode ray oscilloscope. So cathode ray oscilloscope is a very useful electronic instrument which is used in the college laboratories and industries for the measurement of voltage, time, frequency, phase shift, and most importantly for observing the shape of the input waveform. So this is basically CRO. It is basically a voltmeter, but it doesn't give the reading it doesn't display the reading on a meter or on a digital display to read out. Rather, we can observe the reading from this in the form of a display in the form of the waveform. So it uses a screen to display a graph of the instantaneous voltage with respect to time. So these are the images here. So here we can see that this is a type of the output which we obtain from the cathode ray oscilloscope. So we get the output in the form of the waveform on the CRO screen. So it uses a screen to display a graph of instantaneous voltage with respect to time. So rather than getting the reading on a meter or on a digital display, we are getting the output on the screen, and this output is in the form of the graph which is between the instantaneous voltage and with time. So we can say CRO is a type of XY plotter which display the input signal versus the another signal or with respect to the time. Now, what is a pen or the stylus of this XY plotter? So the pen or the stylus of this XY plotter is a luminous spot which moves over the screen of the CRO in response to the changes in the input voltage. So, this luminous spot, since it moves all over the screen, and it is moving at a very fast speed. It moves very fast, and due to the our persistent of vision, we can feel a continuous waveform is being displayed on the screen. So this CRO has many applications. As all of us, we have studied the rectifier and rectified with and without filter circuit. So we can obtain the output of the rectifier directly on the screen in the form of the wave with and without filter. We can also get the output of the amplifier on the screen. So basically CRO is helpful in obtaining the output directly in the form of the waveform on the screen. So this is how a CRO looks like. So you must all have seen in your labs. This CRO, it looks like this. Here we have this blue color screen on which the waveform is being displayed. All these other components, this is a control panel through which we can apply the input voltage, or we can control the frequency, the amplitude, or the phase shift between the waveform. So this is your CRO which you use in your labs. So now we will discuss the construction and working and what are the different components of the CRO. So this is a block diagram of the CRO. So CRO basically it consists of a vertical amplifier, a delay line, trigger circuit, time-based generator, horizontal amplifier. And this portion, which is known as CRT, this is a cathode ray tube. So this is the heart of, basically it's the heart of a CRO. It performs a main function in the cathode ray oscilloscope. So before proceeding further, before discussing the vertical amplifier, delay line and all, we will first concentrate on this CRT. We will try to understand what is a cathode ray tube, what are its various components, and how it is helpful in obtaining the waveform on the screen. So this is the cathode ray tube. So cathode ray, as I have told earlier, that it is a heart of the CRO. It performs a following important function. So first of all, it generates the electron beam. Then it moves the electron beams vertically and horizontally depending upon what type of the input signal we have applied. And thirdly, it displays that input waveform on the CRO screen. So this is a screen on which this type of the waveform is being obtained. So broadly, we can classify this cathode ray tube into three different parts. The first part is the electron gun assembly. The second are the deflection plate, and third is a phosphor screen. So you can see clearly we have this first part. This is a electron gun. Second, we have the deflection plate. These are vertical deflection plates. These are horizontal deflection plates. And lastly, we have this screen, which is coated with the material known as a phosphor. So we will discuss all these components of this assembly one by one. So first of all, we will consider what is this electron gun assembly. Electron gun assembly further consists of the several subparts. First of all, we have a heater, cathode grid. Then we have accelerating and focusing anodes. So the first is your heater and cathode. So from the cathode, we are getting the electron beam. So this is a indirectly heated type cathode which emits the electron. So electron beam is being emitted from the cathode. So after cathode, we have this grid. This is called as a cathode grid. So the function of this cathode grid is to control the intensity of the electron beam which is coming out from the cathode. A negative potential is applied at this grid. So with the help of this negative voltage, we can basically control the number of electrons which are emitting from the cathode. So we can, in other words, we can say that we can control the intensity of the electron beam by using this cathode grid and by applying the negative potential on this grid. So after cathode grid, we have the accelerating and focusing anode. So the electron beam is then further accelerated whenever it passes through the accelerating anodes. So a high positive voltage is applied to the accelerating anodes, and the focus which is helpful in accelerating the electron beam. Apart from the accelerating anode, we have the focusing anode also. So the function of the focusing anodes is to control the sharpness of the electron beam. So by applying the potential across the focusing anode, we are basically controlling the sharpness of the preciseness of the sharpness of the electron beam. So after the electron assembly, we have covered all the parts. First, the cathode grid, accelerating and focusing anode. The second part is the deflection plates. So we have two set of deflection plate. One is a vertical deflection plate and another are the horizontal deflection plate. So the internally generated sawtooth wave is applied to the horizontal deflection plate, which deflects the beam in the x direction, and the signal which is to be displayed on the screen, the input signal, that is applied to the vertical deflection plate, and it deflects the beam in the y direction. And the simultaneous force which is exerted in the x and the y directions, it will deflect the beam in such a way that the waveform will be displayed on the screen. So by the simultaneous working, the simultaneous force which is exerted by both the plates, the resultant electron beam will get modified and we will get the resultant output on the screen. Now this screen, it is a last part, it is called as a phosphor screen, and the inner side of this screen is coated by the special type of the material with special type of the phosphor. And the function of this phosphor is that it converts the electrical energy into the light energy. So the portion of the screen which is hit by or which is struck by the electron will illuminate. And in this way, we will get the visible output on the phosphor screen, and we can visualize basically the waveform which we have obtained in all this process. So that was the basically the construction of the CRT, that is cathode ray tube. All these working part of the CRT, they are enclosed inside an evacuated glass envelope. So let us next try to understand how the signal is displayed on the CRO screen. So as I have told earlier that we have the two type of the deflection plates. One is a horizontal deflection plate, which deflects the beam in the x direction, and another set of the plate are the vertical deflection plates, which deflects the beam in the y direction. And an internally generated sawtooth wave is already applied to the horizontal deflection plate. So a sawtooth waveform, we assume that the potential is Vx, is applied to the right side of the horizontal deflection plate, while the left side of the deflection plate is connected to the ground. The sawtooth waveform is generated by a special unit inside the oscilloscope, and this is called as the sweep generator or time-based generator. So you can see here, we have these horizontal deflection plate. The left side of the plate is grounded and the right side of the plate is connected to the sweep generator. So what is the function of the sweep generator? It generates it generates the sawtooth waveform which is applied to the right side of the horizontal deflection plate. So first, now to understand how this sweep generator or how these horizontal plate deflection plates are helpful in getting the output waveform on the screen, we will assume that we are not applying any signal on the vertical deflection plate. So let us assume that the voltage applied between the vertical deflection plate is 0. That is, we are not applying any input signal on the vertical deflection plate. We are just considering only the sawtooth waveform which is applied on the horizontal deflection plate by using the sweep generator or by using the time-based generator. So as the sawtooth wave is applied between the horizontal and deflection plate at the instant A. This is a sawtooth wave. This is a Vx applied voltage with respect to time. This here I have shown is a CRO screen. So whenever initially at the point A, at the instant A, when the sawtooth voltage is 0, initially when we are not applying any, we have not applied any voltage. So initially the sawtooth voltage is 0 and the spot, the luminous spot or the electron beam, that will be held at the left side of the screen, at the extreme left of the screen. As the Vx or the sawtooth voltage, it starts increasing, as it start increasing, the potential on the right side plate, on the right plate of the horizontal plates, that will start to increase. And in this process, a electrostatic field is developed. And the strength of this field increases with the increase in this Vx, with the increase in the sawtooth waveform voltage. So the field strength will go on increasing. Right? So with the increase in the in this field strength, this electron dot, the electron beam or this spot which was at the extreme left side of the screen, it will get pulled towards the right hand side of the screen. It will start moving towards the right hand side of the screen. So as a sawtooth wave, it is increasing linearly with time. We can see in this portion from A to B, this sawtooth wave, it is increasing linearly with time. So this dot, it will also move from left to right with the uniform speed. So as the voltage has increased from from A to B, the spot, it will move from the extreme left side of the screen of the CRO to the right side of the screen. And at the point B, at the peak value of this sweep generator voltage, this will reach at the extreme right hand side of the screen. So the time taken by the voltage Vx to rise from the point A to B, or the time taken by the spot to move from the extreme left of the screen to the extreme right of the screen, this is called as a trace time. So this is a trace time. So after that, at the point B, after the point B, this Vx, this sawtooth voltage, it will drop back to 0. It will go from peak value to the 0 value. And in this process, the electrostatic potential which was developed, the electrostatic field which was generated, it will collapse and the electron beam will return back to its previous position, that is towards the extreme left side of the screen. And this time during which it moves from the peak to the zero value, this is called the retrace or the flyback time. And at this time the beam is blanked out during this time, and the retrace, this is not observed on the screen. You will not get anything visible on the screen, and again the process will start. So from this discussion we have understood that how by applying the voltage across this horizontal plate, by applying this sawtooth waveform across the horizontal plate, how the electron beam or the electron spot, it moves from the left hand side of the screen to the right hand side of the screen. So with the help of the horizontal plates, the dot or the electron beam move from the left to the right side of the screen. Next, now let us apply the input signal on the vertical deflection plate. Initially, we have considered only that we don't have any voltage applied between the vertical deflection plates. As we are applying that, we have no input signal. We have only the sweep generator which is connected across the horizontal deflection plate. Now let us apply the input signal to the vertical deflection plates. So this is the operation with signal applied between the vertical deflection plates. So vertical deflection plate, they are represented by this Y2 and Y1, and horizontal plates, they are represented by X1 and X2. So whenever the input signal is applied between these vertical plates, the input signal is applied between these vertical plates, then again the electrostatic field will be produced between the vertical plates, which will vary in proportion to the instantaneous amplitude of the input signal. The electrostatic field, it will depend upon, it will vary as per the input signal variations. So on the Y plates, we have applied the input signal, and in the horizontal plates, X1 and X2, already a sweep generator is connected, and with the help of this X1 and X2, dot is moving from the left to the right side of the screen. Now, when input signal is applied to the vertical plates, then the electron beam will get deflected in the vertical direction, meaning in the up-down direction due to this field. So now these two fields are acting simultaneously, one from left to right and another in the up-down or in the vertical direction. So these fields are acting simultaneously in two different directions, and now the electron beam will move up and down while traveling from left to right, and thus the input waveform will appear on the CRO screen by the combined effect of these horizontal and the vertical plate. So that is how the input signal is obtained, the input waveform is obtained or displayed on the CRO screen. Now that was all about the CRT, that is cathode ray tube, the construction, its working, and how it is helpful in getting the input signal on the screen. Now we'll move back to the block diagram of CRO. So we have discussed this part. This is CRT, that is cathode ray tube. We have discussed the different parts of this cathode ray tube and how and we have learned how the signal is displayed on the screen. Now let us talk about the remaining part of this block diagram. So first is a vertical amplifier. So the input signal is not directly applied to the cathode ray tube, as you can see from this image, that input signal, between input signal and the cathode ray tube, we have the vertical amplifier and the delay line. So input signal is not directly applied to the CRT, it is through the vertical amplifier. So vertical amplifier is a very important part of this CRO, because the vertical amplifier, through vertical amplifier, it basically amplifies the input signals. Some input signals are very weak, so with the help of the vertical amplifier, those weak signals get amplified so that we can get a measurable amount of deflection on the CRO screen. Also, this vertical amplifier, it has a wide band width. So it has a very large bandwidth so that it can amplify the input signal over a wide range of the frequencies successfully. So vertical amplifier, it is a wideband amplifier in order to amplify the input signal over a wide range of the frequency. Also in the vertical amplifier, a certain section also contains an attenuator. So what is the purpose of the attenuator? It basically attenuates the high voltage input signal. For example, we are getting a very high voltage input signal. So to control that signal, to reduce the amplitude of that signal to the CRO level, the attenuator is also provided in the vertical amplifier. So the sensitivity and the bandwidth of the CRO is decided by the initial state, that is a vertical amplifier stage. So the output from the vertical amplifier goes to the trigger circuit and another to the delay line. So this output which goes to the trigger circuit is further connected to the time-based generator. So the trigger circuit basically triggers this time-based generator to get the sweep waveform or the sweep voltage. So the function of this trigger circuit is to trigger this time-based generator. Second, we will discuss the delay line. What is the function of this delay line? So the output, the amplified signal from the vertical amplifier, it can, if we do not use a delay line here, then it will go directly goes to the vertical deflection plate. But as you can see here, in the horizontal circuit, we have trigger circuit, time-based generator, horizontal amplifier. Then the signal will be applied to the horizontal plate. So delay line, so this means that the signal will reach at the vertical and horizontal plates at the different times if we do not use this delay line. If we are directly feeding we are directly applying the input signal from the vertical amplifier to the vertical deflection plate. So the input signal will reach the vertical plates earlier as compared to that of the horizontal plate. So horizontal plates, it will get the signal later, and in the vertical deflection plate, the signal will arrive early. So in order to basically compensate this delay of the horizontal circuit, a delay line is introduced between the vertical amplifier and the vertical deflection plates. So this delay line is used to delay the signal applied to the vertical plate. So it will ensure that the signal applied to the horizontal plates and the vertical plates arrive exactly at the same instant of time. So that was about the delay line, so that we can get the signal at vertical and horizontal plates at the same instant of time. Next, we have the trigger circuit. We have already discussed. So the function of the trigger circuit is to ensure that the horizontal sweep signal start at the same point of the input signal in every sweep. The role of the trigger circuit to establish and maintain a coordination or synchronization between the input signal and the horizontal deflection circuit. Next, we have the time-based generator or sweep generator. This we have already discussed in detail in previous slide. So the time-based generator or a sweep generator, the function of this is to generate the sawtooth wave, and then it is applied to the horizontal deflection plate. Next part is a horizontal amplifier. So between the time-based generator and the horizontal plate, we have this horizontal amplifier. Now, what is the function of this horizontal amplifier? So the amplitude of the sawtooth wave is very weak. So in order to amplify the sawtooth signal, which is available at the output of the time-based generator, we use this horizontal amplifier. And then that amplified signal which we get from the amplified sawtooth signal that we get from the horizontal amplifier is then applied to the horizontal deflection plates. Next component is CRT, that is cathode ray tube. We have already discussed the functioning of the CRT earlier. So how we can use CRT to get the electron beam, and how with the help of the horizontal and the vertical deflection plate, we are basically getting a resultant beam on the CRO screen, which is coated with the phosphor material. The last part is power supply. So in CRO, we are the power supply section generates a two level of DC voltage. Here in the CRO, we have the two levels of DC voltage. One is a low level, the low voltage power supply, which is used for the operation of the electronic circuit. And the second, high voltage power supply, it is used for the operation of the anodes in the CRT. And the value of this high voltage is of the order of the 1000 volts to 1500 volts. So we have covered all the parts in this block diagram. So that was it. So I hope you have understood the functioning of the CRO properly. So that's all for the today's presentation. This CRO is a single trace CRO, as I have told earlier. It is the function which we have discussed today is for obtaining the waveform, the single waveform on the screen. Apart from that, we have the other type of CRO trace also, such as dual trace or the multi-trace CRO. So we can discuss those in some next sessions. So that was all for today's lecture. These are some references for further reading. Thank you.